Good day, everyone. In our previous session, we discussed on entity relationship model, where we look at the entity set, the entity side, the entity type. We then look at the attributes. We look at the simple attribute. We look at the composite attribute. We look at the keys. That's the primary key, the foreign key, the candidate key, as well as looking at the association where we talked about the cardinality ratio. Today in our class, we are going to look at database normalization. I remain Mr. Bamanga Mahmoud Ahmad, your guide this moment. So what database normalization means in this class? This is what we are going to look at. Database management system normalization. We know in everything we are doing, if we cannot be able to normalize things, we cannot be able to let things be as they are, it means that thing that we are trying to do is going to be what? Useless. So database management system normalization is a systematic approach in order to decompose tables so that we can be able to eliminate data redundancy and then the undesirable characteristics like the insertion anomalies in database management system, the update anomalies in database management system, as well as the deletion anomalies. Those are the three things or the four things that database management system normalization is concentrated on. One, we are doing database normalization. We know it's a systematic approach that we can be able to decompose our tables. If a table is given in one single table, or information of a database is given in a one single form, we can be able to decompose this table using database normalization approach, so that we can be able to reduce what we call or eliminate what we call data redundancy. Those data that they are just there without any work, we can be able to reduce them. So that if we come to insert any information in the database, this can be avoided also. If also we come to edit, such edition can be avoided. And also when we come to delete, it can also be able to improve our service or activities. So this is a multi-steps process that are being put into what? Into a tabular form. Thus, we are going to remove the duplicate data and then set up the relationship between what? Between these tables. You remember we finished one class. In our previous class, we discussed about cardinality ratio. So here also we are going to what? After we decompose this class, we are going to see how this normalization is going to enforce relationship. So this also is a techniques that we are going to apply the techniques so that we can be able to organize the table in a database. You know, we said all these entities we have been mentioning, they are what? They are in form of tables. So our database normalization can be able to provide with less repetition of data. It's going to provide a large set of data structure into a bunch of smaller tables. A large table that is given is going to be compressed or decomposed to give us a smaller tables. And then the tables must have a proper relationship plan. It's not just like plant without relationship. So why do we need database normalization in our day-to-day database management system activities? One, we need database normalization in order to reduce data redundancy, therefore handling data integrity. Because if the data reputation is there, it increases the chances of inconsistency of data. So when we are talking about data integrity, it means that if I've saved something with with Bamanga, later in time I cannot come back and now find out that this very information of a Bamanga is changed to maybe Bamangan or something like that. So we should try as much as possible to adopt this database normalization in order to what? To stay away from that data integrity issue. So normalization also help us to what? To keep our data consistent by storing the data in one table and then referencing them into another table elsewhere using our foreign key that we have discussed in our previous class. So storage optimization is also available while you're using what? Database normalization approach. So also it helps to break the large what? The large database table into a smaller form, ensuring data dependency, which make what? Data dependencies make sense in their day-to-day activities. That's the logical sort of this data. So in database normalization, we have what we call normalization form. Normalization form are types of database normalization we have. We have them in, we have first normalization form, second normalization form, third normalization form, fourth normalization form. We have Beyond's normalization form or Boyce-Codd normalization form. We have fifth normalization form, 6, 7. It depends on what? The scholar, or it depends on the what? The book you're reading, you're studying. But here I'm going to stop at the Boyce-Codd normalization form. So we are going to look at first normalization form. For a table to be, we have condition on each of these first normalization form. We have first normalization form. What are the conditions for your table to be in first normalization form? That's the first one. It should have a single atomic value or attribute or a column. Thus, in any given table, that table must have a single atomic value. That's the primary key. That's what it means. The first condition. The first condition, it should have what? Contain, or it should have a single atomic value or attribute or column. Are we together? That's number one. Number two, the value that are going to be stored in these two mentioned areas, they should be of the same domain. The values stored in a given column must be of the same domain, right? Must be of the same domain. You cannot come here and you're dealing with students and you will now go and bring like product order or courses inside students. You must create another table there. So this must be of the same domain. That's what they mean. So the fourth one, like all columns in these tables, all these attributes that you are going to have of this must have a unique name. So the name given must be consistent in all the table. So must be of unique name. The attribute must be of unique name. Then the fourth one, you must maintain the order in which this data should be what? Should be stored. Maintain or the order of data stored in a column must be maintained. Right? So this is what? These are the 4 conditions on first normalization form. So we are going to look at this. If, for instance, we have employee table in which we stored employee information along with what? Skill set, the table will look like this. Are we together? We are going to have a table. Somewhere here, we are going to have employee ID. Let's minimize our space. We have employee name. Let's have e-name. And we can just, let's wipe off this. I believe we have taken it somewhere, right? We have employee ID. We have employee name, right? Then we have employee mobile number. Then we have employee skills. So this is a given table. Here we have 001, 002, 003, right? So here first, let's assume we have Yusuf Ali. The second one we have John Omoyele. And the third one we have Friday Betwell. In this employee phone number, we have 1, 2, 3, 4, 1, 3, 4, 5, 1, 3, 6, 7. So in these skills now, the first one, he know how to work with Python. We have comma, we have JavaScript, then that's all. The second person here has HTML, has CSS, then have JavaScript, JS. Let me use JS, JavaScript. The third person here have Java, graphics, and then JS, or C++, right? So this is the what? This is the given table now. They want us to what? To normalize this table. So what we are going to look at first, we remember our first condition in database management system. What is the first condition in database management system? Is say that it should have an atomic value, which is has this our atomic value, right? The second one, they said it should what? They should be of the same domain. They should be of the same what? Of the same domain, right? So if we look at this, very well, here there is a what? A comma separating this. So we should first of all, what? The employee skills column, we know that it holds multiple commas. So therefore we need to what? We need to, as per first normalization form, which violated the rule, we should first normalize this by removing the employee skills column. Are we together? We are going to remove this, or we add multiple rows. We have 2 ways. We either remove this, we create this, the whole of this. We are going to make it, we have another table here, employee skills ID. We have skills ID, and then we have skills. Are we together? So we have skills ID 0001. I'm using 3 zeros here in order to distinguish them from here. we have 0, we need to minimize space because we have 1, 2, 3, 4, 5, 6, and 7. So we have, let's just use 1, 2, 3, 4, 5, 6, and 7. So here we have Python as 1, 2 we have JS, 3 we have HTML, 3 we have CSS, 4 we have CSS, 5 we have Java, 6 we have graphics, and the 7th we have C++. So we have created another table. You remember? So this one of the what? The advantage of using database normalization. So that here, if we come to this very space, we are going to provide. Okay, we are going to provide. We are going to have another table. We are going to have another table. So let's just return this. We have here we have HTML, we have CSS, we have Java, graphics, and C++. So here, this is another table. We are going to have the same table here called employee ID, employee name, then employee mobile, and then skills. So here, now the ID is 001. We know it's Yusuf Ali. Let's abbreviate. We are not doing practical here. Employee name, employee mobile. You put the mobile. Now the skills is having 1, which is 1. The same 001, which is Yusuf Ali, having the same phone number, he's having the same skills of 2. Are we together? The same, he's done. It's only appearing for the second time because we are dealing with the skills. So the third one, this next person now is 002, which is John Omoyele. He's having his phone number and he's having HTML skills. HTML skills is taught. So he's having 3. Then same 002, John Omoyele, he's having what? Another skills of CSS, which is 4. So you are only reflecting the what? The primary key here. So again, same John Omoyele 2. His phone number and he's having a skills of JS, which is 2. Are we together? So you are coming again for the third one, 003, which is Friday Betwell. He's having his phone number here and he's having Java skills. Java skill is number 5. Primary key 5 of this. We have the same 3, computer graphics, which is 6, FB, which is 6, the same thing 3, FB, which is going to be what? C++, that's 7. So you see now, this is how you go about what? Spreading this. You see what your database normalization. They have given you one table, you went further to create another table, end up creating the relationship between this and this. So it means one employee can have many skills, right? One to many. One employee can have many skills. Many skills can belong to one employee. So that's the first normal form, and we have seen the conditions. We have seen how it works. That's in order to normalize these tables or given table in relational database. So the next we are going to look at here is second normalization form, and in second normalization form we also have condition for that normalization form. They say that for the table to be in a second normal form, first of all, it should be in what? In the first normal form. That's the first condition. You cannot jump into conclusion and say that you are running a second normal form or you are normalizing at second phase without your table being in the what? In the first normalization form. That's the first condition. So in the second condition, they say that that table should not have what we call a partial dependency. So partial dependency should not be part of what? Your normalization form. For instance, what they mean by third normal form, that your non-prime key or your table cannot be on a non-prime key. What they mean by non-prime key here is that your what? In relational algebra, your partial dependency occurs when a non-prime attribute, that's attribute that is not part of any candidate key. We have seen our candidate key and we have seen our foreign key, we have seen our primary key. So such table cannot depend on on our composite primary key. So they mean in essence here, if you have a table, for instance, you have what we call product ID or a product ID, which is in form of what? A product table, and you also have what you call order ID is in what? Is in order table. Let's look at it here. This is in order table TBL, right? This is in a product TBL. So you have these two tables. So your partial dependency occurs when you have a product name, you have this product. Under this product, you have product name. So if your product name depends only on your product ID, so are we together? You know, under product name, we have what we call a product name, product description, production date, and whatsoever, what have you. So what they mean here in essence, if this product name depends only on what? On the product ID, that is not entire what? Composite key. It means you have violated this very second normalization code. So it means this should what? Should be linked to another table, meaning that they can be what? They can be linked with another foreign keys in the what? Relational database. So that's what they mean with what? Second normalization form in relational algebra. So if, for instance, we have this, let's look at this table and see how they go. If we have a table with student name, student ID, and a faculty, we have a table like this: student ID as a primary key, we have student name, and then we have faculty, right? So in this scenario, if we have 001, 00002 as what? As student ID. And here we have Yusuf Ali as student name, and then we have John Omoele as name. So under the faculty, here we have computing, here we have education. So this is the table that we are going to look at in this example. So looking at this, we know this faculty does not belong. If this is a given table, this is going to be a given table. Friday the 12th will be in cyber security. Are we together? So this is the given table, right? So we are now going to look at this and then normalize this. So what we are going to do, we are going to have another table which is called faculty. Faculty TBL. So in this faculty TBL, we are going to create a table called faculty ID. Faculty ID as 00, probably 1, 002, 003, and then we have faculty name or faculty itself, just as it is reflected on the given questions. We have computing, we have again education, we have cyber security. So you see now we have this table, but this faculty does not only depend on what? On this faculty. It also depends on the students. Are we together? So it also depends on the students. So this now, we try to create a scenario where we should not have a partial dependency, that this computing does not only depends on students. We end up creating another table called faculty. Likewise, this faculty does not only what? Depends on this faculty table, it also depends on student table. So you can enhance this by what? By creating, instead of having faculty, you can have faculty ID now, or instead of this name, you now inside the faculty number. So in the case that if this Friday Betway is having or is falling under computing, so what you are going to do, this is a computing ID. You should have here 1001. Education is having 002. The same computing here 001. So you are looking at it now. So this is what typical scenario of this. So you can also again enhance this to go further and create courses for this very table, where many students can take many courses, and many courses can be able to belong to what? To many students, and this courses table can also belong to what? To many faculties. That's many students from what? Several faculties can be able to take that courses in that very particular department, or you create another table with a department. So you see, with only this, you can go further and create faculty table, create department table, create courses table, create probably lecturers table. So in essence, this is how you go about normalizing your what? Second normalization form. Considering what? The conditions. First condition state that your form or your table must be in what? In first normalization form. The second condition state, or the second rule state that your table should not have what we call partial dependency. And our partial dependency state that it should not have your non-prime attribute should not depend on what? On the candidate key alone. Are we together? So if the student as a primary key here is a candidate key, your faculty cannot only depend on this. You can go further and break this into what? Creating a further table here, which we end up creating faculty. Likewise, this what if you go by the second rule of second normalization form, your faculty will not depend only on this. It can also depend on what? On your student ID. Are we together? So this is how you go about what? Doing your what? Second normalization form. So the next you are going to look at the what? The third normalization form. In the third normalization form, number one rule state that your table should be or in what? In a second normal form. Your table should be in what? In a second normalization form, that is number one. Number two, it should not have what we call transitive dependency. Transitive dependency. So here, we are going to look at this transitive dependency. Your transitive dependency here state that your transitive dependency exists only when a non-prime attribute, just the way we did this other one, only when a non-transitive attribute depends on another non-prime attribute. So if you have that, a table that only depends on what? On a foreign key, only on a foreign key, not a primary key, it means that table is what? Is on transitive dependency. So looking at this again, if we look at the scenario where you have your product, your students, you have a student ID in a student table as a primary key. Are we together? So your transitive dependency here can occur where your course name, you have a course, right? You have a course title, course code and what have you. So if your course title now depends on only course ID, which in turn should what? Depends on what? Student ID. So here, what we are saying in essence, if that happened, it means you have violated the third normalization form. Are we together? We have student ID here. Are we together? So we also have a course name. A course name. We have a course ID. Are we together? So we have course name, student. We have course name. We have course ID. We also have what we call, if this student ID now, this student ID, if this course name depends on what? On course ID. If this course name depends on course ID, which in turn they say this course ID again should only depends on this instead of depending on this. Instead of depending on this, it means this violated the third normalization form. What they want you to do here in essence, you should try as much as possible to create what we call department ID or department table, and then you create uh, your lecturer table. So that's what we are going to look at here. So we are going to have, looking at the first instance that we are having, or we look at this table where you have student ID. We also have course ID. Course ID. Then we have marks or scores or score or marks. Marks. We have exam type. Exam type. And we also have total marks. Total marks. So if you are having a table like this with the following matric numbers or student ID, this is 3 and this is 001, 002, 003. Again, in the marks you have 70, you have 82, you have 40. Your exam type, here you have theory, you have practical. Then your total marks here should be over 100, and again if this is 50, so if this is what you are having on your board, so we are going to look in the above table, the column exam type, if you look at it very well, depends on what? Exam type depends on student, right? If this exam type depends on the student and the course ID, so if you look at it here, the exam type depends on the students as well as on the course ID, right? So a student can be in any of the faculty we mentioned in what? In the previous table, right? And then based on that, they may have different exam type, right? One may have what? Practical, one may have theory and what have you. So here, how we are going to what? Going to take away this table, we are going to treat this to what, in order not to violate our third normal form, that's considering the transitive dependencies, we are going to create a table called exam type, right? With this exam, we are going to create a table with exam type called exam type ID, right? Then we have exam type. Are we together? So we have another one, total marks or total score. It should be what? Unique. Total marks. So we also have, we probably include duration of what? Of the exam, but we might ignore them if you want. You can include as many what? Attributes as possible if you are trying to what? Carry out your normalization form. So here, we might have 001, 002, 003. Our exam type we know is theory, we know is what again? Theory is this one is practical. So our total marks is 100, 100, and then 50, right? So the same thing here, we can what? Fix this into what? This exam type to also have exam IDA, exam type IDA, just as we have course ID here. Let's assume we have 3 type of courses before the table, right? So here what we are going to look at here again, we have been able to what? Solve this. Are we together? Because we have created this scenario here, we can be able to what? To remove this total score. We can be able to remove this total score, change this to an ID, right? We change this to 001, 002. So we are only left with marks. So here, the marks are not here. Are we together? Only the marks type. So if you want to create that of marks, you should also what? Create exam score table. So this is how you go about what? Treating this transitive dependency. Are we together? So it's a little bit of confusion, but I advise you to what? To be pausing this video, go throughout this step one after the other. Try to jot down some things. But I bet you once we start practical aspect of this, you can be able to what? Get familiar or more understanding into what we are treating now. So that's what the third normal form. And we have what we call Boyce-Codd normalization form. Boyce-Codd normalization form. Normalization form or BCNF. Are we together? So in Boyce-Codd normalization form, this is the what? Based on what we are treating now, I said we have this thing up to what? 8 normalization form, but it depends on the complexity of your relational database. So, but what we are creating now, we are stopping at the Boyce-Codd normalization form, And what we are saying here in Boyce-Codd Normalization Form is what? Is the higher version of the what? Of our third normalization form. So this form deals with the certain types of anomaly, right? So that is not handled in what? In a third normalization form. If you have any anomaly that is not taken care of in what? In a third normalization form. So in Boyce-Codd normalization form, you are going to take care of that. So a third normalization form that does not have what? Multiple overlapping candidate key. This candidate key is a problem in what? In a relational database. So for what? For your table or relational table to be in Boyce-Codd normalization form, it should face what? Meet first normalization form rule, second normalization form rule, and then third normalization form rule. So, and for the table to be what? Satisfied in this, we are going to deal with a mathematical expression of this. Your relational table must be in what? In a third normalization form, as we mentioned earlier. So, and for each functional dependency now, your functional dependency, that's all this, this depends on this and this. Initially, this depends on this and this, and we have removed this and then create this. So these functional dependencies should what? Should be a super key. Now, they should have this on their own. So you are coming here to create another scenario called lecturer table. You are going to create lecturer TBL, right? With what? Lecturer ID, lecturer name, you have the course he's taking, are we together? Or office. So here you are going to have a 00, maybe probably 1 and then 2. You have maybe Dr. AK, maybe Mr. Bamanga, maybe here is in GO6, here is in GO1 or GO7. So again, you are going to create another table called exam score. So each of the affected tables here must have their own what? Their own table, and should be what? Should be related with each and every table here. That's what they mean in the top normal form. So please, if you want to have, in conclusion, if you want to have a base relational database in all your programming endeavor, be it a Java, being HTML, PHP, and what have you, being Python, please, you must practice the way and manners you normalize your tables. Because all these websites that we had of crashing down, they got source from what? From our normalization and the entity relationship model. So we have come to the end of this normalization form. In our next class, we are going to what? Deal with SQL, that's sequential query language, where we are going to exhibit our practical sessions using what we call MySQL Workbench. So MySQL Workbench is what we are going to use in our next videos or next class to create SQL's code. Nice to be with you guys this moment. I remain Mr. Bamanga Mahmoud Ahmad. See you next in our next class. Thank you.